In this video, I'd like to talk about the math question of the day for Wednesday, August 2nd, 2023. And with this problem, we're given two different triangles that we can compare to each other. And we need to solve for x, where x is this missing side length, AC, in this red triangle. And questions like these are typically seen in geometry classes. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And the key idea to look for between these is to compare their side lengths and recognize that these are similar triangles. Since we don't know anything about their angle measures, we can't use any sort of trigonometry to compare the angles. We know these triangles aren't congruent because the side lengths here are significantly different than the side lengths here. But if we're not using congruence or trigonometry or dealing with the angles, then we can compare the side lengths. We can look at the ratios of the side lengths, and if the two triangles are proportional, if their corresponding side lengths are proportional, then we know that the two triangles are similar, and we can figure out this missing side length. Now, if the two triangles are similar and their side lengths are proportional, that means if we look at the longest side on triangle ABC, which looks to be side length 18, this would correspond to the longest side in triangle GFH, which would be GF. And if we look at their ratio, 18 over 9, we can see this is equal to 2. And if that ratio of corresponding sides, when we look at the other sides, is also 2, then we know these are similar. We can do the middle sides, which looks to be BC and GH. If we do BC divided by GH, we get 14 over 7, which is also 2. So in essence, what we figured out is that to go from this triangle GFH to this big triangle BAC, all of the side lengths get multiplied by 2. And if we know this one is 6, that means that after doubling it, this would have to be 12. And we can see that's true because if we take that ratio of AC, the small side here compared to the small side here, FH, we get 12 over 6, which is 2, which is also equal to that proportionality constant. So if we want, we could write that triangle, let's say ABC, is similar to triangle, and here we got to match up the right angles. So the angle between the long and the small side would be F. Then we went to B, which is between the middle and the big one, so that would be G on this side, and then H, which corresponds to C, and they're both between the small and the middle. So that's how we will write that they're similar, but we prove that they're similar by comparing the ratio of corresponding sides. And once we compare that ratio, we can figure out that proportionality constant. We took every triangle length in this smaller one, multiplied it by 2 to get the bigger triangle.